Problem 1, rank these cosine angles from smallest to largest. So we'll start off figuring this out by doing our unit circles. So we know, unit circle, one thing we know is we know at these 2 points, we have, this is angle 180 degrees, this is angle 0 degrees, and also angle 360 degrees. And we know that the value of cosine at these points, so the value of cosine at 180 is equal to -1, while the value on this side over here is 1. And so basically what this tells us is that, and as we go from move over from left to right, cosine will get larger. So basically the way we're going to think about this is the closest things to 180 will be the largest, as they'll be negative, and then as it will be the smallest as they're negative, and the largest ones will be over on this side. So we go through all of these. Cosine of 12 is here, so cosine of 12 will be pretty large, and then cosine of 85 is about over here, so it'll be about halfway betweenish. So yeah, cosine of 165 is around here, so that is very close to 180. Cosine of 180 would be this line right here. So immediately we know that cosine of 180 would have to be the smallest there at -1. So, and then we have cosine of 265, which is right about there, and then cosine of 350, which would be 10 degrees from this line. So we went the smallest to largest. We know the next smallest after cosine of 180 would be this angle right here, so that's cosine of 165. And then next would have to be this line here, and that line would be our cosine of 265. And then after that, it would be this line, which is our cosine of 85. And then next would be these two. So now both of these are very close, but this one was cosine of 12, so it had an angle here of 12 degrees. This one was 350, and so 360 minus 350 is 10, so this would have it. So since this one, bottom one here, is slightly closer, it would be larger. So our next angle would be cosine of 12, and then cosine of 350. So problem 2, find the angles between 0 and 360 have the same cosine as 230. So for this, again, we can draw a little circle here, a unit circle here. So we know this spot right here is angle 180, and then we know we're at angle 230. So if we take 230 minus 180, we would have an angle of 50 degrees here. And since we're using cosine, we know that since it is on the left side here, that this would give us a negative x coordinate. And so if we want to find the same, we need something at the same angle of 50 degrees here, but we need the x to still be negative. And so the only other quadrant where x is also negative is here, which means this angle would be 50 degrees. And to find this would be, that angle would be 180 minus 50, which would be 130. So that would be the same angle there. And then now go to sine, that's 305. So when you think about that, is 305 would be over here, and we know this is angle 360. So we could do 360 minus 305, which would give us an angle of 55 degrees. And we would have, and here at this angle we know that sine would get a negative value for sine, so our y value would be negative. So we need to go in another quadrant that also has a negative value. So we would want to go, so in quadrant 3 here, sine is also negative, and so it would have to be 55 degrees off that x-axis. So this, we would say 50 degrees, so we'd have 180 plus 55. So our angle would be 235 degrees. Problem 3, find 4 positive angles in different quadrants with the same reference angle as the angle 105. So again, we'll draw a circle here. So it's telling us we have the angle negative 105, so that means we'll go backwards from 360 here. So we'd go back 90, and then that would be 90 plus 50. So this would be our 105 angle. But since it says reference angle, our reference angle is always the angle from the x-axis of that quadrant. So if this is negative 105 here, we'd want to find, since it's in this third quadrant, we want to see the angle in this third quadrant. So that would be, so we would do 180 minus 105. So this angle here would be 75 degrees from this x-axis. And we want we'd have a reference angle in every quadrant, and each one would have to be 75 degrees from the x-axis. So now we just need to know what all of those, and so now we just need to know what all of those angles are from our point 0 here. So we'd know one is 75 degrees, and the other would be, have to go to here, which would be 75 plus 30, so that would be 105. And then we'd have one that goes right here is 75 plus 75, so that's 150. So we do 105 plus 150, 255 for next reference angle, and then in between here is just an angle of 30. So we'd do 255 plus 30 be 285. And so our angles would be 75, 105, 255, and 285. 4. Name 3 angles that are coterminal to negative 40, and have 3 angles 7 references negative 40 not coterminal. So coterminal for negative 40, coterminal just means it's in the same spot. So the way to get that is you'd have something coterminal whenever you make a full revolution around a circle. So, and a full revolution is 360. So to get any coterminal angle, we can just add or subtract 360 from what we have. So since we have negative 40 here, if we want one coterminal thing, we could just minus 360 from it. You get negative 400. We do negative 40 plus 360, you get 320. Since we need one more angle, 320 is coterminal, so we could do 320 plus 360 and get 680, and those would be 3 coterminal angles. And then for our reference angles, again, a reference angle is going to be the angle off the x-axis. So we have a negative 40 here, so we'd have this angle here would be 40 degrees. So basically we want every other angles that are also 40 degrees off the relative x-axis. So we could use just these 3 other quadrants here. So we know we could have 40 degrees here, 40 degrees here, 40 degrees here. And then so we know this angle would just be 40 degrees, so that would be one reference angle. This angle right here, since this is 180, here you do 180 minus 40, you get 140. And then here, this 40 degrees is coming off of 180, so we could have 180 plus 40 is 220. So those would be our 3 reference angles. So find the largest and smallest values of the following. So starting with these sine values, property we know of sine is that when it's up here, it's equal to 1. It's down here, it's equal to negative 1. So basically, the closer you are to this top at 1, the larger the sine is going to be, and the closer it is to the bottom, the smaller it's going to be. So we go in here, if we look at sine of A and sine of B look to be the same, so they'd both be the largest as they're closest to that 1. So sine of A and sine of B. And then if we go down, so we go down and look for the next one, would be sine of C, so that would be the next largest. And then next would be sine of D and F, look to be the same, so they'd both be the next largest. And the closest to that -1 is sine of E, so that would be the smallest. And then cosine is about the same thing, except on this left side, cosine is equal to -1. This right side is equal to 1. So basically the opposite, anything closest to this left side will be the smallest, and everything closest to the right side will be the largest. So we can start from this right side. We know cosine of F would be the largest. And then next, cosine of A. And then next would be cosine of E. And cosine of B. Cosine of D. And cosine of C. So find the missing side lengths R and Y for the given triangle. So if we look here, we know we have this angle and this side. So we can view this as using our SOHCAHTOA. So we know we have our adjacent side here, our opposite side here, and our hypotenuse here. So first, if we want to solve for this y, well, that would be our opposite. So that would be opposite over adjacent, so which we know that is tangent theta equals our opposite, which is our y, over our x, which is 3.6. And we know, and so we can multiply that 3.6 over 6 tangent, and our theta would be that 26 degrees, which would be our y. And then next we would have to find our r. We know we have an adjacent side, and we want to find our hypotenuse, so that'd be adjacent over hypotenuse, that'd be, which is cosine, equal adjacent, so our adjacent is our 3.6 over our r, which would give us, so we multiply by the r and divide by the cosine, so we know r would be equal to 3.6 cosine of 26 degrees, which equals r. And then so this, if we calculate 3.6 tangent of 26, it gives us a value of 2.6. And then with our r, if we calculate that, we get 4.4. And make sure when we're doing these calculations that we have our calculator set to degrees mode. Okay, so line passing through the point A10, angle 26 degrees with x-axis. So since it's passing the origin, we can, we know it's passing through the origin, and it's going to point A10 here. So the way we can think of this is as a, we can think of this just as a triangle. So we got this 26 degrees here. We can draw a side down here. We know this side would be length 10. This would be A. So we can just use our trig function. So since this would be opposite over adjacent, so we can do tangent theta equals opposite over adjacent. And we know our opposite side, so we could divide that, so we'd have opposite side of 10 with the tangent of our angle 26 degrees. And that'd be equal to A, so A, and so we type that into our calculator. A would have a value of 20.5. So problem 8, so we walked 100 feet away from a light post, measure the angle from the ground to the light to be 20 degrees. So we think we have our light post here, And she walked 100 feet away, so this would be 100 feet here. And then she's standing here and measured the angle from here to that light post to be 20 degrees. All right, so now, and so we're trying to find the height of this light post. So we think this is, we know the angle and we know one side, and so this would be, again, opposite over adjacent. So we'd use tangent theta equals opposite over adjacent, and we know the adjacent side and we know the angle, so we'd say we'd multiply this a over, so we have 100 times tangent of the angle 20 degrees, which is equal to 36.4 feet. Okay, so problem 9, we need to find the height of B. And look here, so we think for B we have this triangle here. The problem is we only know the angle and not any sides, so we aren't able to solve for anything there. But if we look at this second triangle leading up to this smaller building here, we know the angle 22 and 150. So if we draw that out, either side X, and if we look at these triangles, we can use this triangle because both of these triangles share the same base of X, so we can use this triangle to the left here and solve for our X to solve for our B on this side. So solve for this triangle, and we have our angle and our opposite side, so we can use tangent. So now we have tangent of 22 degrees is equal to opposite, so 150 over X. So we'll solve for X, and X will be 50 tangent 22, which gives us a value of 371.26. So now knowing that, now we can draw this triangle to find the height of B. So we have a height B, and we have this side here, 371, and then the angle for that triangle of 43 degrees. So again, we have opposite and angle trying to find adjacent. So again, we can use tangent. So we know tangent of 43 degrees equals our opposite, B, over our adjacent, 371.26. So 371.26 tangent 43 gives us B as 346.2 feet. So problem 10, we need to convert 5 radians to degrees. So to do that, to convert radians to degrees, so we take our radians that were given and we multiply it by 180 degrees over pi radians. All right, so if we type that into our calculator, that gives us 286.48 degrees. So 11, find the values of r and theta. So first for this, so if we realize we need to solve for theta, we know that somewhere we're going to use the equation S equals r theta. And so first off, we need to find our r. So if we look at this here, at this triangle given down here, it gives us this point. So this tells us for this triangle, we have our x point of negative 2.63, so that would be the x side. And we have a y point, 1.83. So we can solve for r here, so we can use Pythagorean theorem of r squared equals a squared plus b squared. And so that would give us r equals square root of negative 2.63 squared plus negative 1.83 squared, which would give us r equals 3.2. Put that in there. And then, so now to solve for our theta, we have the equation S equals r theta here. And we're looking for theta. We know S and R, so we can take S divided by R equals theta. So, and our S is 12, and our R is 3.2. So that would give us a value of 3.745. And then we need to convert that, and that's in radians, so we need to convert that to degrees. 745 times 180 degrees over pi radians, and that gives us 214.6. Put those in, so we'll have 3.7 radians and 214.6 degrees. So, number 12, find the exact coordinates of the point at an angle 7 pi over 6 on the radius of a circle 2 centered at the origin. So for this problem, we'll want to use our unit circle. So we can pull that up, and on the unit circle, looking at our unit circle, we should see that around this angle right here, this would be our angle of 7 pi over 6. And so the coordinates at this angle here are negative square root of 3 over 2 and negative 1/2. So, and the unit circle is normally for a radius of 1. So if we want, but here we have a radius of 2. And so what you do is you just multiply these coordinate points by whatever your radius is. So since our radius is 2, we'd multiply our point 2 by 2. And that would give us negative square root of 3 and negative 1. And that would be our coordinate. Okay, 13. So we need to solve for the coordinates of this point here. So what we first need to do is, to solve this, we'd use this triangle. So we need to know this angle theta that's in between here. So first what we can do is we're given a radius r, so we know this length, the radius of the circle is 5, and we know that arc length is 14, so we know we have S equals r theta. And we want to find this theta here. So we'd have 14 divided by r5 would be a theta, and that would be a value of 2.8. That theta is for this angle here, and we want this angle here for this triangle. So we know that to make it halfway around the circle, it's pi. So to find the theta we need, we do pi minus 2.8, which gives us 0.34159 radians. And then from there, now we can draw our triangle. So we know we have that angle there, and then we know the hypotenuse of this triangle would just be the radius that we were given, so radius 5. So we need to solve for y and x. So we can just do sine and cosine. So sine of 0.34159 radians equals our y distance over our radius 5. So if we solve for y on this, we will get that y equals 1.67, and make sure our calculator is in radians mode for when we do this calculation. And then now we can do cosine. So we know we have cosine of the same angle, 34159, equals x over radius. So we solve for x, and we get x equals 4.7, but since we are finding this point here, it's to the left, it's on the left side of this axis, so this x would be negative, and so our point would be negative 4.7 and 1.67. So problem 14. So we have another satellite orbits the Earth circular 500 miles above Earth, and then we travel 600 miles along the orbit, and we know the Earth has a radius of 3,960. So if we think about what's happening here, we have a little satellite, which is 500 miles above the Earth's surface, but this angle, angle theta is going to take place from the center of the Earth, so we need the whole distance from the satellite to here, which would also include the radius of Earth. So we know that the total radius would be the radius of Earth plus the 500 miles we are above the surface, which would give us 4,460. and then it tells us that we traveled a distance of 600 miles. So that distance traveled will be our arc length. So we'll say S equals 600. So we can use S equals R theta to solve for theta. So we'll have theta equals S over R, which is equal to 600 over 460, which will result in a theta of 0.1345.